The lesson that I'm going through with you today is lesson 3.6, and it is called Using Perpendicular and Parallel Lines. If you want the title, please pause and write that down. In our lesson today, we have a couple theorems. This first one is Theorem 311. It's called the dual parallels theorem. It says if two lines are parallel to the same line, then they are parallel to each other. I'm probably not going to give you time to get everything written down unless you pause this presentation. So hit pause, write down the theorem, and then turn this back on so I can explain it a bit. Okay, in this thinking, we have three lines. I haven't put the arrows on the ends of them, but there you go. It says if two lines are parallel to the same line. So let's label each of these lines. So if A is parallel to B and C is parallel to B, then, reading the theorem, if two lines are parallel to the same line, I said A was parallel to B, and I said C was parallel to B. So then it says they are parallel to each other, so that would mean A and C are parallel. You might think of some curtains that turn. If one of them turns, then the second one turns, and the third one. That would be an example of this theorem. The other theorem is the dual perpendiculars theorem. In our book, it's number 312. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. Again, pause this so you can get it written down. Okay, to explain this one, we have two lines perpendicular to the same line. So again, let's get our diagram complete. Let's make A and B perpendicular. If A is perpendicular to B and it said two lines perpendicular to the same line. So let's have A perpendicular to B. Let's make also C perpendicular to B. Then it says they are parallel to each other. So it's not that A and C are perpendicular, it's that A and C are parallel because they're both perpendicular to the same line. If this is 90 degrees and this one's 90 degrees, those are like corresponding angles that we've been studying the last couple days. So if the corresponding angles are congruent, then the lines have to be parallel. This is really just a special case with 90-degree angles. Now, if we look around at the room, there are a lot of examples of both of these theorems. Let me flip back to the theorem so that we can see those. Okay, the dual parallels theorem, if you will look up in the classroom, there are dividers in the ceiling that all go the same direction. So you could say the one directly above you is parallel to the one to its right. The one above you is also parallel to the one to your left. And so the one on your right and the one on your left will be parallel to each other. If you look towards the door, there are little tiny wires in the glass of the door. We can set that up with the same kind of example. Maybe it's easier to see the brown dividers. So if the left-hand edge of my door is parallel to the one that's in the corner, and then the one on the right-hand side of the door is also parallel to the one that's in the corner, then the two edges of the door will be parallel to each other. So you can find multiple examples of this one around the room. If you'll, again, look up dual perpendiculars theorem, you can use the dividers there. The one going forward and backwards above you is perpendicular to one that's directly above you, and it's perpendicular to the one directly in front of you. And so the edge the divider above you and the divider just in front of you would be parallel to each other, because they're both perpendicular to the one going towards the front of the room above you. Excuse me, I gotta get a drink of water. If you look at the front of the room, like the marker board, the top of the marker board is perpendicular to the left-hand edge of the marker board. The marker tray is perpendicular to the left edge of the marker board. So it ends up that the top of the marker board and the bottom of the marker board are parallel. Again, a lot of examples in the room. The bricks have a lot of examples also. So between last Friday and today, we talked about 6 different ways that you can get lines parallel. If you'll flip back in your notes, you should find all 6 of them. And they are summarized on page 146 in your textbook. You will need to have all of these in front of you as we go through some examples and you're trying to remember what the theorems and postulates are. So the first one was the corresponding angle converse postulate. Then the alternate interior angle converse. Theorem. The alternate exterior angle. Write all these down. The same side interior angle converse. And then the dual parallels. Theorem, which was 311 in our book. I remember that number because the 11 is like parallel symbol. And then the dual perpendiculars. Which was theorem 312. Okay, now some of the problems we're going to be doing will ask you if there are parallels, and if there are, what the support is. One of these 6 would have to be the correct support, otherwise you do not have parallel lines. Remember that the same side interior angle converse, that's the one, the same side interior angles have to be supplements. 1, 2, and 3, they have to be congruent. Okay, so I'm going to give you some angles and ask you, how would you show that the 2 lines are parallel? And explain your reasoning. I might throw in something where they are not parallel, so be aware. Okay, if I put 70 degrees right here and 70 degrees right here, are lines A and B parallel? And explain your reasoning. Again, you need to try these examples like we do in class. Okay, so yes, these would be parallel, and it would be the alternate interior angle converse. I'm going to change where that 70 is. I'm going to put it here this time. Are the lines parallel? Again, yes, they are. And this would be the postulate 9, the corresponding angle converse. Change that angle and I'll put it here, 110 degrees. And you might say, well, they're same side interior angles, but they need to be supplementary, and they are. It's not that they need to be congruent, it's that they're supplementary. So this is an example of the same side interior angle converse as the support, that there are parallels. Now be careful for problems that are going to try and catch you. If I put 70 degrees and 100 degrees, those are same side interior angles, but they are not adding up to 180. So we would have no parallel lines. So be careful that you are given the correct information. And again, I'm going to give you an angle measure, and you need to tell me which one would make the lines parallel. And what measure would it have to have, support. So let's try one. Let me put angle 1 as 105 degrees. Now, what angle would help me get the lines parallel? And there's multiple answers here. So one possible answer was if angle 5 was 105 degrees, then the lines would be parallel because of the corresponding angle postulate converse. Another possibility, angle 7 being 105 degrees. That would be the converse of the alternate exterior angle theorem. Okay, with angle 1, those would be the only two methods. So let's switch to another one. Let's go to angle 4. Angle 4, let's say, is 85 degrees. Now, if we would know angle 5, how many degrees would it have to be? 95 degrees, because that would be same side interior angle converse. Another possibility would be making angle 8 85 degrees. Now with 4 and 8, that's the converse of the corresponding angle postulate. Remember, you have to have an angle at each intersection, so it does not do any good just to have angle 2, because we've got to have something down below here in order to match it up. So again, watch for problems that don't give you enough information. You do have to have some information at each intersection. So I think we can do one more with angle 4. Think if we would have angle 6 as 85 degrees, that would be the converse of the alternate interior angle theorem. If I would have a special angle in here, let's say angle 3 is 90 degrees. Now if I would know, okay, so these are perpendicular. If I would know perpendicular down here, the two lines would be parallel, and I could use one of the new theorems from today. I could use theorem 312, the dual perpendiculars theorem. Or we could use the converse of the corresponding angle postulate. So that gives us another place that we can use our dual perpendiculars theorem. We looked at this kind of situation the other day. Determine which lines, if there are any, that have to be parallel, and explain the reasoning. I've got line AB, line CD. If you remember, I said you have to ignore part of the picture. So if I would give you this angle congruent to this one, I'm going to bring that screen shade back up. If I would get rid of the bottom part of the picture to block it out, I can more easily see by the corresponding angle converse that the C and D would be your parallels. Now let's change the angle. Let's put that angle down here. Now it's not the bottom that I would want to cover up. It would be this side. So I've got my pair of lines in transversal. Again, I have a corresponding angle converse to get the lines parallel. What would be a no parallels? For instance, if I would go here and here. Because no matter what part I cover up, I get rid of one of the angles. So I can't make two lines in a transversal with those as my angles. Let me switch and put it here. If I move it over, see if I can do this right, slide this way. There, I can get rid of it. So my A and B are the parallel lines, and it's because of the converse of the alternate interior angle theorem. So when you try and determine which lines, if there's any parallels, you have to cover up part of the picture to help you focus. Another type of problem is to tell what value makes the lines parallel. So again, you'll have to look at, let's say this is 80 degrees. Now if I would put the 4x minus 20 equal to 80 degrees because of the converse of the alternate exterior angle theorem, I can solve and figure out what x is. Another example. Let's put an angle right here of 80 degrees. Now the two angles in the picture are not congruent because they're the same side interior angles. The converse says that those have to be supplementary. So in this one, you're not going to set them equal. You're going to set 2x plus 10 plus 80 equal 180. They have to be supplements because they are the same side interior angles. So I'm going to just combine, make that a 90, subtract 90, and divide by 2, x is 45. I'm going to use this same example and move my angle to another position. Okay, so I'm going to get rid of that part. And now I'm going to put an angle right in here, and let's say it's 120 degrees. These are alternate interior angles. They have to be congruent. So this time I would set them equal. So how do you know whether to set them equal or whether to add them up? It depends what pair they are. So are they pairs that have to be congruent or supplementary? The same side interior angles are the ones that have to be supplementary. I think I kind of talked about that one with 2 going each direction. This one's just a little bit more complex with all 3. There's a parallel postulate and a perpendicular postulate that you need to write down. And this is the basis of some of the constructions we did, or will do. It says if there is a line and a point not on the line, so let's take this line L, we'll put a point that's not on the line. It says there is exactly one line through the point that would be parallel to the given line. So let's see if I can draw a line that is parallel to the one that's up there and goes through point P. All right, fairly close. Now it says that there's exactly one line, so that means I can't make another one through that point and parallel to that line that's different than the one I just did. The reason is if I would take this line and move it closer, it's parallel but it's not going through point P. And if I would tip it, can't tip it very well, maybe I can't. If I would tip it a little bit, it's not going to be parallel anymore. So there is a parallel that you can make, and there's only one. There's exactly one line parallel to point L that goes through point P. That's what the parallel postulate tells us. The perpendicular postulate says almost the same thing, but it's with perpendiculars. that if you start with this line and a point that's not on it, you can make a perpendicular through the point, perpendicular to the line. There is one that you can make, and there's only one. Because again, if you tip it, it's not 90 anymore. If you slide it, it doesn't go through the point. Again, pause this if I'm not giving you enough time to write your notes. So we did some constructions previously, and I'm going to have you just try to recall how to do them, because on your homework there will be some constructions. If you get stuck, we'll talk about them tomorrow, but I need you to try those. So we did a perpendicular to a line. If the point is on the line, we started the construction by putting the point of the compass on P, make an arc that crosses the line twice. Then from those intersection points, open your compass a little bit wider, and from one end, make the arc, and from the other intersection, make the same arc. That was making a perpendicular for us. The second one, it is on page 143 if you want to see that. We started with a line and the point that's not on the line. This is very much like the perpendicular postulate just a little bit ago. It says there's going to be a perpendicular that's possible. So from point P, make an arc that crosses your line twice. From those intersection points, you will make the X in order to draw the perpendicular. Makes a 90-degree angle. Oh, we did not do the parallel constructions. So this is just putting some things together from before. I'll sketch it out. We might need to do this in class. But I showed you how to copy angles on Friday in our bell ringer, so you will use that when you do this first one. So we're going to put a line and a point to the side. We want to try and create the parallel that goes through that line. Parallel to that line through point P. So your first step will be make a transversal. Just has to go through P and the line. Now from the vertex here, make an arc that crosses each side of that angle. And from P, do that same arc. Now with your compass, the point of your compass at this intersection, and get the pencil to reach right there. Slide it over and put the point of your compass at that intersection and mark where your arc should, or your angle should end. Now when you connect point P through that X, you should be creating a parallel to the line. And if we use perpendiculars, this will be one that you have to do on your homework assignment. Let's start with a line and a point not on that line. Let's make the perpendicular. Through that point. And now I want to make a perpendicular going up and down through that point. These are just the two constructions from the last screen. So now I ended up with my green line parallel to the black line that I started with. So you have to make a transversal that's actually perpendicular and then make a perpendicular again. We'll practice these two on our class tomorrow. I will be giving you a book assignment related to this section. There's a short worksheet that I'm going to also include, and it just has to do with the slope of lines. These are notes that you should already have related to the slope of a line. These are the new ones. Parallel lines have the same slope. Perpendicular lines have slopes that are opposite signs and reciprocals, which means they would multiply together to be -1. All vertical lines are parallel. Vertical and horizontal lines are perpendicular. Now, the little bit that I'm going to have you do on the worksheet is just identifying parallel lines, perpendicular lines, and lines that are neither. And then looking at the slope. I'm going to give you two slopes. You're going to tell me whether that would indicate the lines are parallel, perpendicular, or neither. Okay, so a couple important things. Parallel lines have the same slope. Identical, same numbers describing their slant. Perpendicular lines, two ways to do this. Perpendicular lines slopes have opposite signs and are reciprocals. I'll practice that with you. And if you want to just multiply the slopes, they'll be -1. So what do I mean by opposite reciprocals? Let's say one line has a slope of 1/3. The slope of one that would be perpendicular to it would be 3/1. That's reciprocal, but then opposite sign. So -3/1, and 1/3 would mean that those lines will be perpendicular. If a slope is -4/5, the perpendicular line would have a slope of +5/4. If the slope is 2, to think about a reciprocal there, think of it as a fraction. So -1/2 would be the slope of a perpendicular. So what you're going to be doing on the worksheet is they're going to give you the slope of line 1, and they're going to give you the slope of line 2, and you're going to tell whether they are parallel, perpendicular, or neither. So for instance, if a line has a slope of 5/3 and the second line has a slope of 5/3, those are parallel lines. They have the very same slope. They'd be slanted the same amount. If we have a line with a slope of -2/3 and one with a +3/2, notice those are reciprocals. They would multiply to be -1. That indicates perpendicular lines. A slope of 1/5 and a slope of -1/5. Now this is an example that would be neither parallel nor perpendicular. They're not the same because one's positive, one's negative. So they're not parallel. But they're not reciprocals and opposite signs because that's what you need for perpendicular, so they're not perpendicular. This would be a neither. They're not parallel, they're not perpendicular, they're going to cross, but not make a 90-degree angle. So a slope of 6 and a slope of -1/6, perpendicular. A slope of 4 and a slope of 4, parallel, and so on. So you'll have a short worksheet and some out of the book. Why don't I write down what that is just to make sure that you have received the complete assignment. All right, so here's what your whole assignment is. Page 147, numbers 1 through 16, 19 to 24, 29 to 32, worksheet on parallel and perpendicular. Can't write. Parallel and perpendicular slopes. That worksheet has 2 sides. Be sure and do both. Okay, I will be back tomorrow.